Welcome to this section of this course. This integration was asked by MIT 2020 Integration B, the qualifier exam. This is question number 11. We have integral root 2 upon 2. Instead of root 2 upon 2, you can consider 1 by root 2. Root 2 upon 2 to 1, sin inverse x upon x cube dx. This we can solve two ways. First way is directly we'll apply integration by parts, considering sin inverse x as this as first function and 1 by x cube as a second function. And another way is you directly substitute u equals to sin inverse x, change the limit, convert everything in terms of u, and you'll have some integral algebraic function as well as trigonometric functions. Then also you have to apply integration by parts. Okay, so their method also you can solve, but I will solve directly applying integration by parts. Now let's apply this integration by parts. This equals to integral. So I will consider sin inverse x as the first function. So sin inverse x. Now integral of 1 by x cube is same as x raised to minus 3, and this same as x raised to minus 3 plus 1 upon minus 3 plus 1 means x raised to minus 2 upon minus 2 means I can say it's minus 1 by 2x square. So integration of 1 by x cube is minus 1 by 2x square. So I can write minus this upon 2x square. Limit is from root 2 upon 2 to 1. Limits I will put later on. Okay. So minus integral differentiation of sin inverse x is 1 upon root over 1 minus x square into integration of this. Second function is we have this. So minus 1 upon 2x square into dx. So this minus and minus become plus. So I can send these two outside. So I can write 1 upon 2. Now let's solve these integration parts. Over here, let's see. Here we have square root of 1 minus x square. Now from here, if I want to take x square common, let's see. If I take x square common inside the bracket, x square common, then this become x raised to minus 2 minus 1. Okay. So now I can send this x square outside. This is same as x square. If I send outside, it become x square root of x raised to minus 2 minus 1. So instead of this, I can write like this. Okay. So instead of this, I can write like this. This is same as x into square root of x raised to minus 2 minus 1. And this x square and x, we have x cube over here. So let's solve this integral. This we already have. Okay. Now if I substitute u equals to x raised to minus 2 minus 1, then my du will be minus 2 x raised to minus 2 minus 1 is minus 3 and dx. Okay. So what this is same as I can send du by, I can send here by 2 is same as 1 by x cube into dx. So what we have is 1 by x cube into dx is become minus du upon 2. Okay, this we have. And let's change the limit. When x tends to 1, let's see. When x tends to 1, then u tends to, when x tends to 1, 1 minus 1 becomes 0. U tends to 0. When x tends to root 2 upon 2, then u tends to 2 minus 1 is 1. Okay. So therefore this integral is become, so integral of this integral become root 2 to 2 becomes, it means 1 to 0. This is what minus, I can send outside du upon minus 2 minus half. This minus half is there, and then square root of, this is square root of u. We have minus half integral 1 to 0 e raised to minus half du. Let's integrate this. Minus half e raised to minus half plus 1 is half upon 1 by 2. Okay, so these 2 and these 2 gets cancelled. So these 2 and these 2 gets cancelled. We have minus of e raised to half. What is u? U is this. So I can write square root of x raised to minus 2 minus 1. Okay, this is for this one. Okay, now let's substitute over here. Therefore this integral, this is equals to minus sine of inverse x upon 2x square minus what we have already half over here. Okay, so we already have over here, so this will be half square root of x raised to minus 2 minus 1, and limit is from here root 2 by 2 to 1. So I'll erase the rest of the things. Now let's substitute upper limit minus lower limit. Sine inverse 1 is pi by 2, so I'll have minus pi by 2 upon here 2 minus here 1 minus 1 is 0, so everything becomes 0 over here. Upper limit minus lower limit. Root 2 by 2 is same as 1 by 2. Sine inverse root 2 is 45 degree. Okay, minus pi by 4 upon 2 into 1 by root 2 the whole square, means these two gets cancelled, minus. So now if I substitute 1 by root 2 over here, so 2 minus 1 is equals to minus pi by 4, here minus plus pi by 4 minus plus half. Okay, so 2 minus 1 is 1, so these two gets cancelled, so we have only half. It is the required answer. Now another way to solve this problem is, as I told you, let's substitute directly. Now let's substitute u equals to directly sine inverse x. Now my du will be root over 1 minus x square into dx. Therefore square root of 1 minus x square is equals to into du is my dx. So from here what I can see is, from here x equals to sine of u. Okay, if u equals to sine inverse x, then I can say x equals to sine u. Okay, therefore square root of 1 minus, what is x? X is sine square u. Sine square u du equals to dx. 1 minus sine square u is what? Cos square u. So taking square root, it become cos of u du equals to dx. So I have dx in terms of u. Now I need x cube. So x cube means what? From here x cube you can find is same as sine of sine cube u. So we have everything, so we can convert. What about limits? When x tends to 1, okay, now u tends to sine inverse 1 is what? Pi by 2, 90 degree. Okay, and then when x tends to 1 by root 2, then u tends to 45 degree is pi by 4. So let's substitute over here. So this is become integral, here pi by 4 to pi by 2, here pi by 4 to pi by 2, sine inverse x is become u, and x cube is up 1 upon sine of cube u into dx is cos of u into du. So we have everything in terms of u is equals to sine cube, I can write is same as sine square u into sine u. Okay, means 2 plus 1 is 3. So cos by this is equals to integral pi by 4 pi by 2 u into 1 by sine square is what? Cos square u, and cos by sine is cot of u into du. Okay. Now here what you can do is you can use integration by parts, considering this as another function and this as another function. Okay. And we know that differentiation of cot u is what? Minus cosec square u. So you can find this integration easily, and then you use integration by parts, eyelet or DI rule, DI methods or tabular methods. Okay, and then you will get the same answer as previous one, 1 by 2. Okay, same answer you will get.